Okay. So here we have a dictionary. Now, what is a dictionary used for? It's used for finding the meanings of words. But nowadays, we rarely use these kinds of thick fat dictionary to find the meanings of words. We generally resort to Google. Now, dictionaries were used before when internet was costly. Moreover, we didn't have the privilege of Google, right? So then people used to resort to dictionaries for finding the meanings of words. Now, let's try to do an activity. Let us try to find the word cat in this book, in this dictionary, all right? Now, how would we go about doing that? Well, one of the approaches would be to simply turn the pages one at a time and try to find the word cat, right? So now we are at A, and next we're going to turn the pages one after the other to find the words that begin with C. This does not begin with C, nor does this, nor does this, nor this, nor this, and we can keep on turning the pages. You can go on doing this. And after some time, well, not some, after rather a pretty long time, we will arrive at words beginning with C and then finally at our word that we want to search, that's cat. But let me ask you a few questions. What do you think? Is this algorithm correct? Well, yes, you are right. This algorithm is correct. Now, is this algorithm fast? Way no. It's pretty slow. If I would have told you to find the word palindrome instead, it would have taken you hours following this approach, right? But it begs the question, is there a faster approach? Yes, there is. And that is binary search. So, let us next try to find the words cat and palindrome through binary search. Alright? Let's see what binary search tells us. Well, binary search tells us to start our search from the middle of the book, right? So, to go to the middle of the book, I roughly half the books and I come at the middle. Well, I have two words. I have membrane and I have medal. Well, let me just zoom in a tiny bit. Well, I guess that's fine. You can see it right now. Alright, so we required 1 turns, right? Every time we half the book, I'm going to write it as 1 turn, right? So we required 1 turn. Now, we are searching for the word cat. Now, does cat come before or after M? Well, sure, it does come before M, right? Therefore, we can neglect this part of the book. We can neglect these many pages because we are sure that cat will come in the left half because it lies in the left of M towards A, right? So with this approach, we reduced our problem from thousands of pages. Well, this book contains approximately 1,000 pages. So from 1,000 pages, now we only have to search for the word cat in 500 pages, right? So we reduced the number of pages where we need to search. So let's search in the left half. So we're going to do the same thing over here again. We're going to half this, right? And this is at the second step, all right? Okay, so let me put a marker here. Okay, now we are at D. Now, remember the word that we are searching. We are searching for the word cat. Now, what do you think cat would lie? Would it lie in the right half or would it lie in the left half? Well, it would lie in the left half, right? Because C comes before D. Therefore, we can neglect this many pages and we can continue our search here. So from 500 pages, we have now come to approximately 250 pages, right? Let's half this. Okay. Roughly speaking, we have half this and we have come to words beginning with B. So this is bun and that's buffet. Alright. Now, where do you think the word cat would now lie? Would it lie in the left half or would it lie in the right half? It would surely lie in the right half, right? Because C comes after B. So from 250 pages, we have now reduced our search to 125 pages. So at every step, we reduce the number of places we need to search by half, right? Let's search for a cat in this place. All right, let's half this many pages, and let's put a marker here as well. And now we are at words starting with C. So we are close to our solution. But we are at complex. It begins with C, O. And we are at compact that begins with C, O as well. So C, O and C, O. But we need to search for the word that begins with CA, right? So in which half do you think CA would it lie? Would it lie in the left half or would it lie in the right half? Surely left half, right? Because CA would come before CO. Alright? So let's search in the left half now. Alright? So this, we have halved our pages again and we are at step number 4. So we have the word CEDE and we have the word CHAFE. We need to search for the word cat and that's CE, so CA would lie before CE. Alright? So you're going to have these pages. You see how we are reducing the problem, reducing the size of our search. And we are now at CA and can and capacity. Alright? So, where do you think we must search next? Should we search in the left half or should we search in the right half? Well, T comes after P. PQRST, right? Therefore, we must search in the right half. So, we are at step number 5. Now, we are going to half this. And we are at CAR. We have Karen and we have case. PQRST. So we need to search here, alright? So we are at step number 6. Now, if I halve this, and finally, after 6 steps, we have the word cat. Voila. So, see, it was faster, ain't it? So, how many number of steps did it take us? Well, for searching the word cat, it took us 6 steps, right? Well, that's not dark enough. Let's make it. It took us 6 steps. Alright? Now, let's see. You might now think maybe that was a fluke, right? This algorithm working and I getting at the word cat. Now let's try to search for another word. Now if we are able to search that word, that would mean that this algorithm does work. So let's search the word palindrome now. So the same drill all over again. We start from the middle of the book and then we go on halving our search area. I don't know if that's a word. Alright, so we are at long term and we are lopsided. Well, I'm unable to make equal halves of this book, and that is the reason why we are at L and not at M, right? So this wouldn't occur in computer where we would implement this program. It's difficult for me to exactly halve the book, and that is the reason why we are currently at M and not at L and not at M, right? So this was one step, and we know that P is after L, alright? So we're going to search in this half of the book. So, same drill, we roughly half the book. Now we are at R. Now we know that P would be before R, and that is the reason why we need to search restrain and retribution. So we need to search in the left half, right? So let me halve this again. And we are at P. So now, this is P. Okay, see? starts with P. We are at P. Now we need to search for the word palindrome, and this wouldn't be in this half. See, this half contains O, alright? This wouldn't be in this half. It has to be in this half, right? Now, I'm going to halve this again. So it took us 3 steps till now. So we are at pre-marital and presentiment. So tough word. And we need to search for the word palindrome, right? So palindrome, PA, would lie to the left of premarital. PA, right? We are at PR. So we're going to search in this half. And that would be step number 4. We have this. Okay, we have pejorative and penniless. And we know we need to search for PA, palindrome, so it's going to be in this half. We are at step number 5. Let's have this. And we are at paper. And we are at PA. We need palin, P-A-L. Do we have palindrome here? Well, we don't. We need P-A-L. Now we know that P-L would lie before N. So it's going to be in this half. Alright? So we are at 6 steps now. Let's have this. And we have the word palindrome. So this does work, right? So for searching the word palindrome, even that took us 6 steps. That doesn't mean that it's going to take 6 steps for all the words, right? So the choice of words was such that it took us 6 steps. Well, now what would you conclude? Is this algorithm faster or is it not? Well, I'd say this is faster. Well, at least faster than linear search, that is. You can find a word in 6 steps. Alright. So, now, let us see why this works. Well, this works because in a dictionary, the words are arranged in alphabetical order, starting from A to Z. Right? Let's show this to you. So, in a dictionary, the first words begin with A, and the last word begins with Z, right? So, because in a dictionary the words are arranged in alphabetical order, therefore this particular algorithm works. Now, binary search always requires a sorted list, right? Without a sorted list, we can never say whether this particular letter would lie to the left or would it lie to the right. All right. Now, let us say why this is faster. Well, this is faster because every time our problem is divided in half. So we were starting from the middle of the page. We were starting from the middle page, roughly the middle of the book, and then our problem was reduced from 1000 pages to 500 pages. Now, 500 pages, from 500 pages we are reducing it to 250 pages. Now from 250 pages we are reducing it to 125 pages. So this is bound to be faster, right? We are reducing our problem in half every single time. And this is exactly what we are going to do in our array. In our array, we are going to set the searching location either would be to the left of the middle or it would either be to the right of the middle. So I hope you understood that binary search isn't some sort of an algorithm that is implemented only in computers. Well, it can be very easily shown. I've even shown it to you here that it can be used practically for finding words in a dictionary as well, right? So this algorithm does work. Now that you have understood the analogy, let's see how we are going to implement this for searching an element in an array. Alright, see you in the next video. Bye for now.